didn't do 20 yet? Section 8.1. Did we do 20? Did we do 20 or did we? Okay, I can do 20. A squared plus 7a minus 8, and then it's a squared plus 6a minus 7. Now, is it okay if I just kind of work above and below when I factor, then I don't have to rewrite? So what we want to do is factor the numerator. And notice there's no common factor. Trinomial, it's not a special case. And therefore, if it factors, it's going to factor as a pair of binomials. And the leading terms are going to be a. Now the sign is going to be what? Plus and minus. Very good, Tristan. Because this is negative. Now then, that 7, because it's plus or minus, is going to be a difference, right? So what two numbers times itself is 8, whose difference is 7? 8 and 1. Okay. And the 8, which is the larger number, must be positive. Very good, Tristan. So now that makes that this one's factored, right? Now the denominator, it's descending order, leading term positive. It's a trinomial. It's not a special case. So if it factors over the integer, it's going to be a, and the signs are what? Because this is negative, it's plus and minus, right? Opposite signs. Now that 6 has got to be a what? Difference. So two numbers times itself is 7, whose difference is 6. 7 and 1. And which one's got to be positive? The larger number, because it's positive here. So that's a 7 and a 1. So we have that one factored. Now we look for common factors in the numerator and denominator. And notice that there's an a minus 1 up here and a minus 1 down there. Those are multiplicative inverses of each other. Therefore, their product is 1. So then the answer here in the numerator is a plus 8, and the denominator is a plus 7. And that's completely factored. So if we look at 24, here it says 4 minus y squared, and then the denominator is y squared minus 3y minus 10. Now that numerator, before you factor it, what you want to do is get it in descending order with the leading term positive. So what's going to have to happen? If you went descending order, I'll put an extra step in. If you go descending order, it's a negative y squared plus y. But now you want that leading term to be positive, so what do you have to do with that? Factor a minus sign out. So if you factor a minus sign out of the numerator, you can put that minus sign right out here in front, just as a minus. Minus in the numerator is the same as a minus out in front, which is the same as a minus in the denominator, right? And then this becomes y squared minus 4. Are you good with that? Now then we can factor that numerator. It's a binomial what? Difference of squares, isn't it? It's y that's squared and 2 that's squared. So that binomial difference of squares, if you look in the algorithm, it says it's y plus 2, y minus 2. That's what that factors into. Does that make sense? So we've got the numerator completely factored. Now the denominator, notice it's descending order, leading term is positive. It's a trinomial, it's not a special case. So now if this factors, it's going to factor as a pair of binomials. It factors over the integers. The first term is going to be y, right? What's the sign going to be? It's opposite, because that's negative. It's opposite signs, plus and minus. Now, because it's plus or minus sign, that 3 right there is a sum or a difference. Which one's going to be? It's going to be a difference. So what two numbers times itself is 10, whose difference is 3? 5 and 2. Which has got to be negative? The 5 must be negative. The larger number must be negative, because that, in order to get that negative 3. So any question on how that's factored? Now we've got both numerator and denominator completely factored. And what you look for is like terms. What is the like term numerator and denominator? Y plus 2. You see, when you put those over top of each other, they're multiplicative inverses, they become 1, right? We think of canceling, but it actually becomes 1. So now what you have left is you, on the right here, I'm going to write, you have a minus out in front of a numerator that has a y minus 2 in it, and a denominator that has a y minus 5. Now notice, I could bracket the y minus 2 and I could bracket the y minus 5, but that straight line underneath there acts as a bracket. It becomes a bracket. Now if you had some other binomial in the numerator that is multiplied by the binomial that's up there, then you'd have to bracket them. So this is the answer. Any question on that? So 28. It says 2n squared minus 9n plus 4 all over 2n squared minus 5n minus 12. Now I want to look at the numerator first. And notice it's a polynomial, descending order, leading term positive. It has no common factors, right? So now, if that thing factors, it's going to factor as what? A pair of binomials over the integer. Now the first term of each binomial is going to be what? N. What are the signs going to be? That plus for that constant term means same sign. What sign? Negative sign, right? So both of these are negative. Now, because both of the signs are the same sign, this 9 is a sum, right? It's a sum of the integer factors. 1 and 2, 4 is 1 and 4, and 2 and 2. Now what combination gives me a sum of 9? It's the 2 times the 4 and the 1 times the 1, right? So now because both of these are negative sign, that 1 and 4, which it's this combination and this combination. The 1 and 4 goes wherever I want to put it because they're both negative. But now I have to place this 1 and 2. How am I going to place that? The 2 has to go with the 4, don't it? So you're going to have to put the 2 out front so that it goes with the 4. And then the 1 would go here, but you don't put it there, right? So now that numerator, I'm going to cross it out. That's its factorization. Now we go to the denominator. Descending order, leading term positive. Whenever you're factoring these things, you always want to set it up that way so that you have it factored. So it's a trinomial, leading term positive, descending order, not a special case, right? If this thing factors, it's going to factor as a pair of binomials. You're going to have what? N and N. What are the signs going to be? Okay, because that's negative. That's right. It's a positive or negative. That's right, Trevor. Now then, because those are positive and negative, what is this 5 going to be? A sum or a difference? It's going to be a difference when they're opposite sign. So we're looking for integer factors of 2, integer factors of 12, and then we're trying to get combinations so that we get a difference of 5. So can you see a combination such that the difference is 5? What combination are you going to go with? It's the 3 and the 4, isn't it? The 2 with the 4 is what? 8. And the 1 with the 3 is 3. And 8, 3, the difference is 5, right? That's the way it has to be. But now we have to decide for that 3 and 4, which one goes in which position. Well, this is negative, and that says the 3 or 4, whichever one is involved in the larger product, has to be negative. Which one is involved in the larger product, the 3 or the 4? The 4. 2 times 4 was 8. That was the larger product. So the 4's got to go negative. The 3 has got to go positive. Now we have to place the 1 and the 2. The 1 goes there, so that it's with the 3, and the 2 goes here, right? So it's with the 8. Now that completely factors that one. Now what we're looking for, because we haven't completely factored, we're looking for common factors. What is the common factor? Okay, the n minus 4, when you put them over the top of each other, they're multiplicative inverses. They become 1, right? Now, what does that leave this problem to be? Numerator is 2n minus 1, and the denominator is 2n plus 3. I don't have to put brackets because what? The line brackets it. Now, the next group of problems, it's telling you to multiply these. Now, what you want to do when you multiply them, you want to reduce them to lowest terms and then multiply them. So 30 says 8x squared over 9y cubed times 3y squared over 4x cubed, right? Now, if you were to just multiply those, do you see that you could put them all like that, and they're multiplied. Numerators are multiplied across, right? Now then, what you can do is what you want to do is look at them and see if you have common numbers, numerator and denominator, or variables, numerator and denominator, that will cancel things out. Well, first of all, let's just start in the numerator. You see we have an 8 right here. Is there something in the denominator that I could use to cancel with it? The 4. You see, 4 will go out, and if you take a 4 out of here, you have what left? A 2, right? Now we can just go left to right across the top. You have an x squared. Look in the denominator. You have an x cubed, right? Well, you can say this x squared, if I take an x squared out of x cubed, I have an x left, right? Now you look at the 3. Well, you got a 9 in the denominator that you can cancel some things out of, right? That 3 would go away in the numerator, and if you took a 3 out of 9, you'd have a 3 left, right? Now, the next variable across the top is y squared. You have a y cubed in the denominator. What would happen? You just have a y in the denominator, right? Take a y squared out. Now then, just accumulate what's in the numerator left. There's just a 2, right? And in the denominator, you have a 3yx. Now, probably this would be written as 2 over 3xy. Why is that no different than 2 over 3yx? Community property multiplication says you can write them in any order you want, right? You can put the 3 in the denominator in the middle, at the end. You could mix those things up, no matter whichever way you want it. Book may give you this in terms of the answer. Okay. 34. 34, it's saying 3x minus 6 over 5x minus 20 times 10x minus 40 over 27x minus 54. Now, probably the best thing to do with this thing is say, if I wrote these as, being a product, as 1 in the numerator, 1 in the denominator, I would, if I put brackets like that, right, that would be the same thing as what was written in black. But I'd have to bracket those, correct? I'm just writing over with red so I don't have to rewrite it. Because it says multiply the numerators, multiply the denominators. That's what definition of multiplying rational polynomials or rational numbers is. Now then, what I want to do is I want to start with this 3x minus 6. Can I factor it? It's written in descending order, leading term positive. How would I factor that? Take a 3 out and get an x minus 2, right? That's factor. We're going for prime factors. What are the prime numbers? Now look at this next one. 10x minus 40. What's a common factor there? Okay, 10. Take a 10 out and we get an x minus 4, right? Now look at the bottom left. 5x minus 20. What's the common factor? 5. And you got x minus 4, right? That's factor. Now look at the 27x minus 57. What's the common factor? 27, isn't it? 27 comes out, and you have what? X minus 2. That's factor. Any questions about that? Now just start across the top. You got a 3. Is there anything in the denominator that would work with it? The 27 would, wouldn't it? You're going to take a 3 out of the 27, and so what do you have left? A 9, right? 9 times 3. See, technically, this is what I've done, is I got 3 times 9 is 27, and I said these 3 go away, correct? Because they're multiplicative inverses. Now I look at my x minus 2. Well, you notice I have an x minus 2 down here. Those are multiplicative inverses. When you put them over top each other, they become 1. So they go, you cancel. That's, now you look at the 10. What goes with the 10? Well, the 5, right? The 10 is 2 times 5. And then the 5 in the numerator, 5 in the denominator, are multiplicative inverses. Now, next one is x minus 4. You got an x minus 4 in the denominator. Those are multiplicative inverses. So my answer is what? 2 over 9, right? That's what's left. Thirty-eight says x squared plus 5x plus 4 over x cubed y squared times x squared y cubed over x squared plus 2x plus 1. Now if I put those numerator and denominator, I can put my line straight through, right? But I better bracket this, right? And bracket this. Same thing in the denominator, I better bracket this and bracket this. Now technically, this wouldn't have to be bracketed, nor would that, but just to be consistent with the way you're doing it. Now, look at this x squared plus 5x plus 4. It's a trinomial, descending order, leading term positive. Want to have it that way. It's not a special case, although the first term is squared, the last term is squared, 2 squared. The middle term would have to be what? 4 for it to be a special case. Then it could be x plus 2 quantity squared. It isn't. So now if it's going to factor, it's going to factor as a binomial pair that has x and x. What are the signs going to be? Same with what sign? Plus. See this one, this plus in front of the constant says same sign. This says the sign is plus. Now, 1 and 4, 2 and 2, because of the same sign, the 5 has got to be what? A sum. Which do we use? Okay. 4 and 1. That one is factored. Now this one right here is just comes up here as x squared. Oops, no, I don't want to do that. I'll go to my x squared. Oops. My x squared. And I look at my x squared here and my x cubed down there. What does that do? just an x in the denominator, don't it? My y squared goes out, and this becomes just a y in the numerator. Now, how does that thing factor? It's a trinomial, descending order, leading term positive. Is it a special case? Well, this is a squared term, x. The 1 is a squared term, it's 1. Is the middle term 2 times x times 1? Yes. So this is a special case. X plus 1, the quantity squared. Now this is not meant to be a minus sign. Now, you see, I have this x plus 1 in the numerator, and that x plus 1 squared in the denominator. So this one goes out, and it leaves what? 1x plus 1. So now my numerator has an x plus 4 in it, and a y. And my denominator has a what? X times an x plus 1. That's my answer. Okay. So it's 2x squared minus 5x. This thing is over 2xy plus y times 2xy squared plus y squared over 5x squared minus 2x squared cubed. So now I can write this as this term times that term in the numerator times that term times that term in the denominator. Now let's look at the first binomial, 2x squared minus 5x. Is there a common factor? Notice it's descending order, leading term positive. It takes, an x comes out, don't it? And it has 2x minus 5. Look at the next term in the numerator. Is there a common factor? So a y squared comes out, and you have a 2x plus 1. Notice this term right down here. What has it got in common? A y, don't it? Take a y out, and you got 2x plus 1, don't you? Now, this next term, notice it's not descending order, and the leading term is not positive. If I wrote it in descending order, it would be a minus 2x cubed plus 5x squared. But now the leading term is not positive. So what do you have to do that? Factor a minus sign out. When you factor a minus sign out, that minus sign in the denominator you could move it right up here, right? Making the whole thing negative. And then write this as a 2x cubed minus 5x squared. Now, does that thing have a common factor? Has an x squared common. And you'd have a 2x minus 5. Now everything is prime factor. Just go up on the top and look at my x. Notice I have an x squared down here. So this x would go away, and this would just become a x, right? I have a 2x minus 5 here. I have a 2x minus 5 down there. Those go away. Now notice, if I had not taken a minus sign out of that denominator, this would, down here, this thing here, would have been 5 minus 2x, right? Okay, now then, I have a y squared. Notice the y down here makes that y squared a y. Then I have a 2x plus 1, 2x plus 1. Those are multiplicative inverses. That goes away. Now my answer is this negative sign, right, minus y is left in the numerator over x is left in the denominator. And there's my answer. X squared minus plus 2x minus 35 x squared times there weren't brackets in there, but we're going to need them anyway when I do that. So I'll need those brackets when I do this. Now, this term, how does it factor? It's a trinomial descending order leading term positive. It's ready to factor. It's going to be it's a binomial pair. What are my signs? Plus and minus. Two numbers times itself is 35, whose difference is 2. 7 and 5, isn't it? And what's positive? 7 positive, 5 negative. Now this one is descending order leading term positive, no common factor, trinomial, not a special case. The factors, it's going to be a binomial pair, x, and the signs are what? Opposite. So that means that 3 is a difference. Two numbers times itself is 18, difference is 3. What is it? 6 and 3. And the 6 has to be positive. The one down here, that's a trinomial descending order leading term positive, no common factor. It's got, if it factors, it's a binomial pair, x and x, different signs. Now then, the 4's got to be a difference. Two numbers times itself is 21, difference is 4. 7 and 3, isn't it?
Yeah.
Positive 7, negative 3. Next one, trinomial descending order leading term positive, no common factor. It's not a special case. If it factors, it can be a binomial pair, an x and an x. The signs are what? Same sign plus sign. So that 9 in the middle is going to be what? A sum. What two numbers times itself is 18, whose sum is 9? 6 and 3. Now we look for common factors. X plus 7, no x minus 5, x plus 6, x minus 3. Notice what we have left is an x minus 5 in the numerator over x plus 3. Now, I don't have to bracket those because that line is acting as the bracket. want to see any more. I mean, it's just the same thing over and over again. They just get a little bit harder on factoring. I'll look at 56. Notice this is divide. What is the thing you have to do when you divide? You have a divisor, a dividend, and a quotient, right? When you divide 56, here's 4x, dang it. I'll do it. 4x squared y cubed over 15 a squared b cubed divided by 6xy over 5a cubed b 5. Okay, remember when you divide, you have a divisor, dividend, and quotient. Can you anyone tell me which one is the divisor? Which one of those two is a divisor? Which one's the dividend? This one's a dividend. This one's a divisor. I don't know for sure. Probably not spelled right. The quotient is a result, right? Now what do you do when you divide? You invert the divisor and multiply, right? So this goes 4x squared y cubed over 15a squared b cubed. Then you multiply and you invert the divisor. Then you're doing the same process we did before, right? You put it a single line. Now this, because there's no binomials or trinomials or anything, you don't have to put brackets. And so then you go 4. Is there something in the denominator that goes with it? The 6, right? You can take a 2 out of the 4 and leave 2, 2 out of the 6 and leave 3. The x squared. Notice there's an x in the denominator. This goes away, this leaves an x. Then it's y cubed. There's a y in the denominator. Y goes away, and you have y squared, right? The 5. 15 in the denominator. 5 out of 15 is 3. You have an a cubed. You have an a squared down here. Leaves you an a in the numerator. Here's a b5, b3, leaves a b squared in the numerator. So then your numerator is going to be 2x y squared a b squared over 3 times 3 is 9. Now, probably in the book, and I would not say it's wrong how you write it, but it usually is alphabetical order. That's by convention. Then you could have 2 times that, all over 9, or 2 ninths, I don't know. This is okay. That's okay. It's just... Okay, I'll do another one, 60. Now this one, the dividend, I'm going to leave it just the way it is. But I'm going to multiply and I'm going to invert that divisor so I don't have to rewrite it. It's 3x minus 9 over 6x squared plus 7x. Because I don't want to have to rewrite it. So now what I'm going to think of this is it's all over one over the other, and I'm going to bracket these because they're binomials. Now then, I'm going to start right up here. What's a common factor? It's a descending order leading term positive binomial. Common factor, x squared, right? Times 6x plus 7. That one's factor. Now the next one, is there a common factor? A 3, right? This is 3 times x minus 3.
It's supposed to be 36.
What?
36.
Oh, it's supposed to be 36? Well, then 9 comes out. Right? And 9 comes out, then this whole thing is wrong. The 9 comes out, and then it's 4x. 9 comes out, it's 4x minus 1, right? Now do I have it right? This one down here, 3 comes out, right? And that's a 4x minus 1. And this one, an x comes out, don't it? An x times 6x plus 7. Now we look at this, and there's an x goes out, it makes this just an x. 6x plus 7, there's a 6x plus 7, multiplicative inverses, becomes 1. The 9 and the 3, you take the 3 out of the 9, there's 3 left. 4x minus 1. So now, my answer is 3x. So that finishes 8-1. In 8-2, what we're going to do is we're going to do something called least common denominators. Multiples. 8-2. It says LCM. That means what? Least common multiple. I'll just look at that number 2. It writes 6AB squared, and then it has 18AB cubed. Now what you want is you want to have a number that both of these will divide into, and the way you do it is you prime factor everything. This is 6 is 2 times 3 times A times B squared. So that's a prime factor. The 18 is 2 times 3 squared, AB cubed. Now each one of these prime factors in the numerator denominator must occur in the least common multiple to the highest degree they are in either one. So 2 to the first power is in both of them. 3 to the second power is the highest down here. So it has to be the prime factor to the highest power. Then it's A, and the highest power in either one of them is 1. And then the B, the highest power in either one is 3. So my least common multiple is that number right there. That's how you figure it out. Then you can expand it. The 3 squared is 9. 2 times 9 is 18. AB cubed. This is okay. But that's what we're going to do, because what we're going to do is we're going to work with polynomials. And you're going to have to factor the polynomial. And then factor be it a binomial or trinomial, for whatever power has got to be in common. Because what this leads you to is the least common denominator. And then the least common denominator is what you have to have when you add or subtract rational polynomials. So that's where they're going. And then you have to build your fractions in order to add them together. So that's where we're going to in this thing. Okay, that's it.